exponential expressions, and today we're going to talk about simplifying radical expressions. And here's a hint, radicals are actually the same thing as exponents. And they look different, and so people get confused about that. But just like fast forwarding for a moment to the back of your notes so you can get this idea. Remember from last class that if you have m to the 5 6, that can be expressed as the 6th root of m to the 5th. So sometimes, like if I need to do a cube root, for example, and I don't feel like trying to find the menu for cube root, I might do m to the 1/3 power on the calculator because it's the same thing, okay? So this is the reason why exponents are the same thing as radicals. Here we go. So a radical can undo an exponent. A little bit of craziness here. A radical can undo an exponent. For example, square and square root will undo each other because they are inverse operations. If you're trying to do something like cube root of 125 in your head, if you understand what a cube root is, you can do that because we know that 125 is 5 to the 3rd power. And then the cube root and the cube will cancel out, giving you 5. All right, so cube root of x squared does not simplify any further because cube root and square are not inverses of each other. Undo. Undo. But just like we can simplify the square root of x squared, we can also simplify the cube root of x cubed, the 4th root of x to the 4th, the 5th root of x to the 5th, etc. Like that. Bless you. So anytime you have the same exponent and the same index, this is called the index, here's your vocabulary word right here, then they will cancel out. And usually the examples start with the most simple and go to the more complicated, and so I'm going to go to example 4 before I ask you to work on some. So let's look at these. 32, f to the 11, g to the 14. I'm looking at example 4. It's a 5th root, which means we're looking for something to the 5th power. I'm going to take that 32 and I'm going to break it up. So 32 could be 16 times 2, 4 times 4, and then 2 times 2, 2 times 2. So when I break it into prime factors, how many 2's do I have? I have 5 of them. You see that? 1, 2, 3, 4, 5. And that's good news because that makes 2 to the 5th. So when I simplify this radical, I'm going to have the 5th root of 2 to the 5th. And then f to the 11, I want to break that up into pieces that I can use as well. So remember that when you multiply the same base, you add the exponents. I can break up f to the 11 into f to the 5 times f to the 5 times f to the 1. Now, it might not have occurred to you to break it up that way, but think backwards, and do you believe this? F to the 5 times f to the 5 times f to the 1, does that give you f to the 11? It does. Okay, and then g to the 14, I need to also break it up into 5s as much as I can. So I can do g to the 5 times g to the 5 times g to the what? If I'm trying to get to 14, how many more g's do I have? Yeah. G to the 4. Okay, let me pause there for just a sec. All right, so 2 to the 5th and the 5th root, those are inverses, and the 5's will cancel, giving me just 2. The same thing with this f and this f, so I have f times f if you like to do steps together, you could just make that f squared all at once, but I just like to show everything. This one does not come out. This one is not an inverse, it's gonna stay. G to the 5, G to the 5, those can come out, G times G. But this one is not an inverse because the 4 doesn't match the 5. So I still have a fifth root, and I still have f to the 1, which is just f, times G to the 4. And then remember that we can simplify this too. So 2 times f is f squared, and g times g is g squared. Fifth root, f times g to the 4. Okay, going back to 1, I'm going to do a factor tree for 54. I've got 27 times 2. 9 times 3, and 3 times 3. So I have 7 cube root 3 to the 3 times 2. What can come out of that root? What number can come out of that root? The 3 can, yeah, because it has an exponent of 3 and a root of 3, and so those will cancel out. So you get 7 times 3, and then cube root, I still have a 2 underneath it. The 2 is stuck there, and that gives me 21 cube root 2. I'm going to box these answers up. All right, 112. A lot of us didn't know what divided into 112, but you just chose 2, and that was a good choice. So you did 56 times 2, right? 56 times 2. And then again, if you didn't know, you could do 28 times 2, but some of you did 7 times 8. That was a little bit of a shortcut. 4 times 2, 2 times 2. And so what you ended up with was 2 to the 4 times 7. So we've got fourth root still. Fourth root, 2 to the 4 times 7. Now because the exponent on the 2 matches the index of the root, that can come out, that's 2. But you still have fourth root of 7. Questions on that? Okay, and then the next one has a number and it has variables, so we had to do both of those things. So for the 250, I did 125 times 2, 25 times 5, and 5 times 5. So I had 5 to the 3rd times 2. The a to the 5th, I needed to break it into as many a to the 3rds as possible, so I took out a to the 3rd and I was left with a squared. And then how many b to the 3's could I make out of this? 3b to the 3's. So b to the 3, b to the 3, b to the 3. So the 5 comes out. The 2 has to stay. A comes out, and a squared has to stay. And then I had b, b, b. All right, the 2a squared stayed under. And now I'm going to simplify this. So I have 5a b to the 3rd cube root 2a squared. Questions? All right, Another thing we need to know about radical expressions is that your final answer can never have a radical in the denominator. This is going to come up in future math classes a lot, especially if you do trig or if you do pre-calc with trig. You will need to know how to rationalize the denominator. And it's actually quite simple in this case. Whatever root you have in the denominator, you multiply by that same root. When you see a square root on a fraction, it's really the same as if the square root were on the top and on the bottom. And root 3 is not a problem, but the root 10 is a problem because you cannot have a radical in the denominator. So you multiply by that same radical. And root 10 times root 10 is root 10 squared. So I get root 30 over root 10 squared. And the square and the square root undo each other. So I get root 30 over 10. And I don't know when mathematicians decided that having a radical in the denominator was just too messy to deal with, but I think it just has to do with being able to simplify these in your head. You know that root 30 is somewhere between 5 and 6, because root 25 is 5 and root 36 is 6. And then if you divide that by 10, that would be like between 0.5 and 0.6. So you can actually estimate this in your head. And mathematicians decided a long way back that a final answer should not have a radical in the denominator. We'll do number 8, and then I'll give you a minute to do 6 and 7. Okay, let's look at 8. In 8, we have 4 root 15x. The 4 is not a problem. It's the root 15x that's a problem. So that's what we multiply by, just the part that is under the radical. All right, I get 3 root 15x over 4. Now, this is going to give me root 15x squared, so it's just going to become 15x. You can write that step out if you want, root 15x squared, or you can just make it 15x. All right, so I got rid of the radical in the denominator, but my fraction is still not simplified. What part of my fraction do I still need to simplify? The x is okay, and I'll tell you why. It's because this one's under a radical and this one's not, but I have two numbers that are not under a radical. What are they? 3 and 60. 3 and 60, that will simplify. Now, if you like to do that in your head, you can think, okay, I can divide them both by 3 and do that. Or if you want to do that in Desmos, Desmos does that very nicely too. Let's look at Desmos real quick. Three over 60, and then you press this, okay? 1 over 20, or on your calculator, you can do it as well. Then you need to press the math button. It's over here under alpha and fraction. And again, you'll get 1 over 20. So any way you like to do that in your head, on Desmos, on the calculator, it works. But 3 over 60 simplifies to 1 over 20. And so I get root 15x over 20x. Okay, number 6. We need to get rid of the root 5, so that's exactly what you multiply by. I get 10 root 5 over root 5 times root 5, which is root 5 squared. The square root and square cancel. So 10 root 5 over 5. And then am I done? Not quite. One more step. I got to divide 10 by 5. 10 divided by 5 gives you 2. So I saw some people write 2 root 5 over 1, which is not wrong, but it would be more simplified to just write 2 root 5. Just that. Okay, so you no longer have a fraction because 10 divided by 5 was 2. Okay, next one. This one, again, it has a radical on the whole fraction. That's really the same thing as if it had 2 different radicals. If it was root 2 over root 3. So don't let that throw you off. And then we need to get rid of the root 3, so we do times root 3 over root 3. And we get root 6 over 3. And that one does not simplify because the 6 is under a radical and the 3 is not. So you can't simplify those two. All right. I like doing the first and the last, so that's what we're going to do here. First and the last. I want you to remember that this 16 to the 3/4 is the same thing as a radical. Does the 3 or the 4 go in the index here? The 4 does, that's right. That means the 3 is the exponent. No, that's a good, it could have been if it was like the number 5 or something. However, we can rewrite 16 as a power of 2. What is it? 2 to the 4, right. So 16 is equal to 2 to the 4. Now, if you didn't know that off the top of your head, no problem. You can make your factor tree like that. So now you can see that 16 is 2 to the 4. So I have 4th root, 2 to the 4, to the 3rd. 4th root of 2 to the 4, those will cancel, giving me just 2, but I still have to the 3rd power. Now 2 to the 3rd, remember, is not 6. 2 to the 3rd is 2 times 2 times 2, which gives you what? 8. Yeah. 2 times 2 is 4. 4 times 2 is 8. All right, I'm going to do the last one. For the last one, there's really more than one way to do it, but whenever I see that power to a power, I kind of want to multiply my exponents. Remember that that was your exponent rule. If you have a power to a power, you multiply exponents. So I would get 8 to the 2/3, x to the 6/3, because I did 2 times 1/3 and 6 times 1/3. Now the x part simplifies pretty nicely because 6 over 3 is just 2. For the 8 part, I'm going to write that as a radical. So I'm going to make this x squared. That's going to go right here. This I'm going to make cube root of 8 to the 2. Now if you know the cube root of 8 is 2 off the top of your head, because you know that 2 times 2 times 2 is 8, you don't have to show steps. You can just tell me that's 2. That's okay. But if you're having trouble, it's okay. Make your factor tree. 8 is 4 times 2, 2 times 2. So I have x squared, cube root, 2 to the 3, to the 2. Hello. So this and this will cancel. Thank you. And I have 2 squared. So 2 squared is 4. So I have 4x squared as my final answer. Number 10. We had to rewrite this as a root to start. So the 2 would go in the index and the 3 would go out here. And it's not wrong to write a 2 in the index, but you've been writing square roots since like elementary school, right? And when you write square root, we just don't put a 2 in there. So you can put the 2 here if you just like having that routine and doing the same thing each time, it's fine. But if you see a root without a number, you should know that's a 2. All right, then for the 9, you can rewrite 9 as 3 times 3, which is 3 squared. So I have square root of 3 squared to the 3. Square root of 3 squared is just 3. So you have 3 to the 3. 3 times 3 is 9, times another 3 is 27. You should get 27 as your final answer. All right, the next one is a power to a power. So you're going to multiply your exponents, and you get x to the 12 over 2. What's 12 over 2? It's just 6. So it's just x to the 6. That wasn't too bad, right? Questions before we move on? Okay. These are going to be a little bit trickier, but I'm going to do the first and the last again with you and see what you can do with the others. 13 and 17. Okay. When radicals have the same index, see they're both radical 4, you can put them together. So because they have the same index, that can become the same 4th root of x squared times x. And that x doesn't have an exponent, so I'm going to make it x to the 1. And it's just 4th root of x cubed, and it's that simple. So when they have the same index, you can multiply and divide them and put them together. But a problem like number 17, they have different indices. Let's look at 17. The index of the denominator is 3. What is the index of the numerator? It is 2. Good. Remember, if you don't see a number in there, that's an index of 2. When they have different indices, that's the plural of index, then you're going to change to fraction exponents. Okay, so the numerator becomes x to the 7 over 2, and the denominator becomes x to the 2/3. We subtract them, yeah. So when you divide, you subtract exponents. So this becomes x to the 7 over 2 minus 2 over 3. Now you might remember like 5 million years ago when we had our last class that we reviewed fractions at the end. And this is the reason why. Because when I divide, I have to subtract my fraction exponents, and now I need to get that common denominator. So I'm going to make a common denominator of 6, and the way I'm going to do that is by multiplying the first fraction by 3 over 3, and the second fraction by 2 over 2. And I'm doing that to get that common denominator of 6 so I can actually subtract those exponents. So I have x to the 21 over 6 minus 4 over 6. 3 times 7 is 21. 3 times 2 is 6. 2 times 2 is 4. 3 times 2 is 6. With the common denominator, I can now subtract them, and I get x to the 17 over 6. Now that is technically an answer, but because the problem started with a radical, I'm going to put my answer as a radical as well. So to make my answer a radical, I just translate that back. Remember that it's going to be 17 as the exponent and 6 is the index. So the 6 goes here, and the 17 goes here. So compare that to problem 13. Problem 13 was easy because they had the same index. Problem 17 was harder because they had different indices. Looking at 14, 15, and 16, which ones will be easy because they have the same index? Yeah, good. 14 and 15. So 14 and 15, you can do those like 13 where you just put them together. But then 16 will have to be done in the same way we did 17. So take a few minutes, work with your group on that. Okay, so we said 14 has the same index, so we can make this a great big radical like this, right? X to the 3 over x to the 1. All right, so once we write this as one radical, remember when you divide, you subtract exponents. So I have square root of x squared, and those are inverses. They cancel, giving you just what? Just x. Nice. Okay, 15, same radical, so you can put them together, and you get x to the 3 times x to the 5. Now, some of you might have canceled that out right away, and that's okay if you did it like that. It doesn't really matter, the order. And so then I get cube root x to the 8. And then I'm going to break this 8 up. So I have cube root x to the 3, x to the 3, and what's left? X to the what? To the 2. So x to the 3 times x to the 3 times x to the 2 gives me x to the 8. These x's will come out. And then x times x is x squared. So I get x squared cube root x squared. All right, in 16, we have different indices, 5 and 2. So I'm going to change them to fraction exponents. I get x to the 1/2 times x to the 3/5. When you multiply, you add exponents. So I have x to the 1/2 plus 3/5. And what will I make the common denominator? It is going to be 10. Basically, you're looking for the least common multiple of 2 and 5. And in this case, it's 10. Often, it's just going to be the product of those two numbers. But if they had a common factor, it might have been a little trickier. So I'm going to multiply this one by 5 over 5 and this one by 2 over 2. So I get x to the 5 over 10 plus 6 over 10. Which is going to give me x to the 11 over 10. And that's going to be the 10th root of x to the 11. However, notice I have more x's underneath than my index, so I can actually take an x out of that. So once you get here, this 11 is bigger than the 10. I'm going to break the x to the 11 into x to the 10 times x to the 1 so that my x to the 10 part can come out. I have x 10th root x as my final answer. Okay, so multiplying across, I'm going to put the 5. X squared times x to the 4 is x to the 6 because I added the exponents. Y to the 1 times y squared is y to the 3. And then on the bottom, I'm going to put the 2, then the x to the 1, and then y to the 1 times y to the 3 gives me y to the 4. All right, 5 over 2 does not simplify. They don't have any common factors. X to the 6 over x to the 1 does simplify. When you divide, what do you do with exponents? You subtract them. Good. So I'm going to keep the 5 over 2. I'm going to subtract these exponents, and I'm going to get x to the 5th. And when you're trying to figure out if it goes on the top or the bottom, just look, where do you have more x's? Do I have more x's on the top or on the bottom? On the top. So my x to the 5 goes on the top. For the y's, there's really more than one way to approach it, but I'm going to explain with my way, which is just subtract the bigger number minus the smaller, 4 minus 3. You get y to the 1. And then where do you have more y's, on the top or on the bottom? The bottom has more y's, so the y to the 1 goes on the bottom, and you're just done. So I'm going to start in the same method for this problem. I'm going to multiply across anything that doesn't have an exponent. I'll give it a 1. It's really not the only way to start. I just like to do the same thing. It helps me. So 6 x to the 7, y to the negative 3. 4 times 9 is 36. X to the negative 3, y to the 7. So multiplying across, I added the exponents. And now what I'm going to do is wherever I have a negative exponent, I'm going to do the reciprocal. That will move it to the other part of the fraction with a positive exponent. So I'm going to keep the 6 over 36 for now, even though I know in the back of my head that's going to have to simplify. I'm going to keep the x to the 7 because that's a positive exponent, but this x to the negative 3 moves up here. The negative exponent becomes positive. And then the y to the negative 3, that moves down here, and the negative exponent becomes positive. So I only move the terms with a negative exponent. I only move this one and this one. All right, the fraction 6 over 36 simplifies because they have a common factor of 6. 6 over 36 simplifies to what fraction? It is 1 over 6. So 6 over 36 becomes 1 over 6. X to the 7 times x to the 3 gives me x to the 10. Y to the 3 times y to the 7 gives me y to the 10. Convert from radical to exponential. So I'm going to make the fraction 2 over 5. Some people would like to write their answer as 3a to the 2/5. You would need parentheses if you wrote it that way. Or you could put that exponent on each part. So you could write 3 to the 2/5, a to the 2/5. So either of those two answers would be acceptable.